Okay. My screen is visible, right? And like if my voice starts breaking or if you feel like that my screen is lagging, let me know at that very instant, okay? So I hope it's not breaking right now, but anyways. So in this problem, this is the first problem of yesterday's round. So in this problem, we are given that there are n people subscribed to Petya's channel. And now at the start, there are already a subscribers online. Now, whenever a subscriber goes offline or comes online, Petya gets a notification. So there are a total of Q notifications that Petya receives. Now we want to just like know, is it possible that all the n subscribers have read the post? Whenever subscribers come online, she reads the post immediately. Okay. So is it possible that all the n subscribers have read the post? Is it possible that is it impossible that all the n subscribers have read the post? Is it possible that all the n subscribers have read the post? Or it is guaranteed that all the subscribers have read the post? So this is an easy problem. Let me see. In order to solve this problem, there are already n subscribers online, right? And then you're given a string of something like plus plus minus minus plus plus. So plus denotes that a subscriber is coming online, and a minus denotes that a subscriber is going offline. So if at any instance, see, there are m subscribers already online at the beginning. So if you start processing this and if you find, see, this means that now the subscribers that are online are m plus 1. This means that the subscribers that are online are m plus 2. This means that there are right now at this instant there are m minus 1 subscribers online. This means that there are m minus m subscribers online. This simply means m plus 1, and this means m plus 2. So these are the number of subscribers that are online at the very instant of this second, right? Or at the instant of this notification. So if at any point you find that the number of subscribers are equals to that are online are equals to n, then the answer is always yes, right? It's guaranteed that all the subscribers have seen the post. Is it making sense? Yes, no, anything? Is it okay? Like this guaranteed case. Okay. So now coming to whether it's possible or whether it's impossible. See, there are m subscribers initially online, and assume that each of the subscribers that is coming online next is a different subscriber. So just count how many pluses you are getting in this string and add m to it. If this total value is more than or equals to n, you'll say maybe the all the n subscribers have seen the post. But if this total value is itself less than n, that means that all the n subscribers like didn't even came online. So then you'll have to output no. Is it clear? Yes, no, anything? Okay, so I'll show you the implementation quickly. So this is the implementation. In this, I'm first taking n, m, and number of notifications, that is q, as input. Then I'm taking string s as input. Then this is the maximum. Like maximum is nothing but at an instant, what is the maximum number of subscribers that are online, and total is, like I said, m plus all the pluses that I'm getting. So at if I get a plus, my number of subscribers that are online at this instant gets increased by 1, otherwise it will get decreased by 1. Finally, I'm updating my max value, max value. Then I'm also updating my total value. Total is nothing but if I'm getting a plus, I have one more subscriber that is online. Then after this, if mmmax is equals to n, that means at an instant there were all the n subscribers online, I'll output yes. If this total value is more than or equals to n, I'll output maybe. Otherwise, I'll output no. So I hope this is clear. So let's go to the second problem. My voice is not breaking, right now. Okay. So coming to this problem, we are given a permutation P1 to Pn of integers 1 to n. Now you can change the current permutation by applying the following operations, possibly 0 times or maybe more than 0 times. Okay. So what are the operations? You choose some x between 2 to n, and then you create a permutation. Like you first write down all the elements that are less than x, and then like you don't change their order, and then afterwards you write all the elements that are more than or equals to x without changing their order. So you have to find how many operations are required to sort this initial permutation. So let me show you something here. See, first of all, let's say the permutation was something like 2 1 4 7 3 6 5. I have all the elements, right? 1 to 7. So this is a permutation of size 7, of length 7. Now let's say I'll pick up 5. So first I'll write all the elements. Okay, let's not pick 5. Let's pick, what should I pick? So let's pick 6. So first you'll write all the elements less than 6 first. So what are the elements? 2, 1, 4, 3, and 5, right? And then I'll write all the elements that are more than 6, more than or equal to 6. So that is 7 and 6. Is it like, have I done this correctly? Can you once check? This is what I'll get, right? If x is equals to 6, right? Yes, no, anything? Okay. So now if you notice, see, there are n numbers, right? In a permutation, there are n numbers. After I sort this, I should have exactly this thing. 1, 2, 3, 4, 5, all the way up till n. So 1 should come before 2, 2 should come before 3, 3 should come before 4, all the way. Like this will keep continuing, right? So if in case, like in this case, 5 was not coming before 6, right? 5 should come before 6. So if I chose 6, the only thing that changed was now 5 is coming before 6. All the other elements, like 2 was not coming before 1, it is not coming before 1 right now. 2 was coming, like 2 should come after 1, but it's not coming after 1, right? 3 should come after 2. It was coming before also, it's coming after also. So for all the other elements, x and x, like for all the other elements, let's say other elements are, all the elements are y and y plus 1. So for all of these elements, nothing, their respective positions won't change. The only thing that will change is for x and, like if you chose x and x minus 1. So if you're choosing x, the relative position of these two will only change. So you just have to check for how many values 1 to n you're getting position of I more than position of I plus 1. So you'll keep this checking from 1 to n minus 1. I will go from 1 to n minus 1. If thing is true, you'll have to select I plus 1. There is no way around this, because if you select anything other than this thing won't change. So you just check how many elements, for how many values this is true, and this is your final answer. Is it clear? Is it clear, or you want me to take an example? If it's clear, I'll show you the implementation. Okay, I'll show you the implementation. So first, I'm taking array A as input. Then I'm marking their positions in this position vector. So position of AI is I. Then my answer is initially 0. Then I'm going from 1 to n minus 1. And I'm calculating if position of I plus 1 is less than position of I. Like this should be, I should come before I plus 1, right? But if position of I plus 1 is less than position of I, I'll increase my answer by 1. Finally, I can print my answer. So is anyone having any doubt in this? Okay, so let's go to the next problem. So this is mix repetition. Now in this problem, we are given an array A of pairwise distinct integers from 0 to n. So this is very important in this, pairwise distinct integers between 0 to n. So then we have to consider the following operation. We'll consecutively for each I from 1 to n in this order replace AI with max of A1 to AN, like for max of all of these integers. Now what is max? Max is the maximum excluded integer. For 0, 2, 2, 1, 4, the max is 3, because 3 is not included in all of these numbers. But actually this is not a permutation, okay? This is just an example. You are not given a permutation, but you're given a pairwise distinct integer. So this is not actually present in the input, this kind of thing, because you have pairwise distinct integer. This can be present in the input. So max of this thing is 0, because 0 is not present. So maximum excluded non-negative integer, that is max. Now let's, so after we are given also an integer k, and after k operations, after we have performed k of these operations, we have to print the final array. So first of all, is the problem statement clear to everyone? I'll take an example. Let's say 0, 1, 3, and we have to perform the operations once. So if I perform the operations once, see what is my, I will start from here. So what is the currently the max of this thing? Can anyone tell me what is the max of this thing right now?
2.
Yes, it's 2. Then my array will become 2, 1, 3. Now this is the complete first operation. Now the first operation hasn't ended. Now my I will come to this place. Max is 0, so I'll write 2, 0, 3. Then my I will come to this place. My array will become 2, 0, 1. If you look at the answer for this test case is 2, 0, 1. If you had multiple operations, you'll again apply. So this is complete one operation. This will be your second operation. So you'll keep applying this thing k times. Finally, the array which you get is your answer. So now how to solve this? See, array values are between 0 to n, including both values, right? 0 to n. So now, how many values are possible in this range? N plus 1, right? And your array is of size n. So there is exactly one value between 0 to n which is missing. So let's look at what actually happened when we had this 0, 1, 3. When we had 0, 1, 3, see what is happening. If you look closely, after one operation from 0, 1, okay, max, how is, not max, I'm not saying max, I'm saying max. Max is maximum excluded non-negative integer. So 0 in 0, 1, 3, 0 is there, 1 is there, 2 is not there. So maximum excluded means not maximum, minimum. It's not maximum, I'm sorry. It's minimum excluded non-negative integer. So you'll have to look the first non-negative integer which is missing in the collection. So now coming to this thing, see, after one operation from 0, 1, 3, you got 2, 0, 1. Now let's one more time let's apply this operation on 2, 0, 1. So max of this thing is 3. You'll get 3, 0, 1. Then once again, you'll get 3, 2, 1, and then you get 3, 2, 0. Is it right? Yes. So now you have 3, 2, 0. So if you look closely, and after this, you'll again get, okay, let's not worry about what we'll get, but let's see what's happening. See, here you're calculating max. So here you'll always get the max of this complete array, right? After this, the value which was at this place is now not present in the complete array. Why? Because from 0 to n, you were given distinct elements. So each position was having one element, and that was unique to it. No two positions were having the same element. So once you wrote the max of this thing here, this value, that is 0, is now missing. That is not present in the complete array. So the next position will have 0, and here we'll have 0. 2 will come here, 3 is coming here. But how to actually connect this completely? So let's also include one more. See, you are given n elements, right? 0, 1, 3. You're given 0, 1, 3. So let's also add one element to this, which is max of these 0, 1, 3, which is 2. So after this, it's nothing but each time after each operation, these elements will, and this 2 will come to the first place. 2, 0, 1, 3. So this is the first operation. After the second operation, all these elements will again shift forward. This 3 will come here. 3, 0, 1, 2. So after the third operation, your array will become, can anyone tell me? After the third operation, what will be the array? Anyone? 2, 3, 0, 1. Yes, it's right. So 2, 3, 0, 1. So actually, when you'll be printing your answer after k operations, you just have to print the first n elements, not the all the n plus 1 elements. But how to solve this? Now the problem is really simple, right? How to solve this? After k operations, what is actually happening? You're rotating. See, and you're not going in, like you're not rotating your array in, like your eye won't shift in this direction, but you're going backwards. So how to solve this? Just rotate your array k times. If you have all these values, assume that you have all of these values. So after one operation, let's say you're starting from this place. After one operation, you'll start from this place. After two operations, you'll start from this place. After third operation, you'll start from this place. So if k is 3, you'll first print this element, then this element, then this element, and then this element. You only have to print n elements. The size of the modified array is n plus 1 because you have added one max element of these elements to the end of it. Now, how to do this? How to come backwards? See, you have to do k operations. K is going up till 10 to the power 9. So how to, anyone, how to get the position from which I will start? See, I'll tell you. Yeah, you can take modulo. See, if k is, let's say, see, after one operation, you'll end up here. After two operations, you'll end up here. After three operations, you'll end up here. After four operations, you'll end up here. After five operations, you're again starting from this point. And what is the, by the way, length of this n plus 1 is also 5. So just see, after all the operations that are k, if you do k modulo n plus 1, so these are the actual rotation that you should be worried about, because all the other operations will simply make you end where you started, like will make you come to the first place only. So first calculate k is equals to k modulo n plus 1. Now after this, you have actually some values left, so those will matter. So how to get this? It is nothing but now n plus 1 minus k. So n plus 1 minus k simply means if k is 1, you'll end up here, because n plus 1, you're subtracting 1 from n plus 1, so you'll end up here. If you have k as twice after this thing, so you'll end up here, otherwise you'll end up here. So do you get my point? So this is the place where you should start from. So let me write it completely. N plus 1. And it's possible that after this point, k is 0. K is a complete multiple of this thing. So you have to take a modulo of this thing also. So this is the place where you start from. Is that okay? Is this thing okay to everyone? Like, I won't be able to debug your implementation right now, but you can raise your query. But is this thing clear? Like, is anyone having any idea in this? This is my starting place, and I'll just print my arrays from array elements from this thing, and I'll print n elements. If the total number of elements right now in my array are n plus 1. Is this thing clear? Okay, what about others? Is it clear? Yes, no? Okay, if n is 1, nothing changes, right? If n is 1, if n is 1, then, and see, let's say k is anything. So if n is 1, you'll have two elements in your array, n plus 1, right? V0 is 6. How can be V not? How can be the first element be 6? Array elements can be only between 0 and n, right? Either this will be a 0 or n. How can it be a 6? Okay, so I think this is clear. So let's go to the implementation. So this is the implementation. Now I'm taking n and k as input. Then I'm taking array a as input. So this is me just calculating the max. I'm inserting the max of the all of these elements in my array a again. So by the way, you don't actually need this because all the elements are between 0 to n. You can just create an array and you can mark all the elements that are present in that array, and there will be only one element between 0 to n which is not present in the array. So you can do it that ways also. But you just have to calculate the max of all of these elements, and then you'll insert that element at the end of your array. So now my starting position is nothing but n plus 1 minus k modulo n plus 1, and again taking the mod of this thing. So finally, I'll have to print n elements. I'm starting from S, and each time I'll increase this by 1. But as I reach the last position, I have to go back to the 0th index, right? So in order to do that, just take the modulo of this thing with n plus 1. So after you reach n plus 1, you'll have to go 0 to the 0 index. Is it okay? Is it okay? Yes, no, anything? Okay, perfect. So let's go to the next problem. So coming to this problem, in this problem, we are given that there is an n cross m board divided into cells, and there are some dominoes on this board. Now each domino covers two adjacent cells, that is either it is laid horizontally or vertically. Now Pete thinks that this board is too boring and it needs to be painted. So now he will paint the cells of the dominoes either black or white. And he calls the painting beautiful if all the conditions below are met. So what are the conditions? The first condition is for each domino, one of its cells is painted in white and the other one is painted in black. So a domino is of like a domino consists of two cells, right? Two adjacent cells. So one of the cells should be covered in white and the other one should be covered in painted in black. So then for each row, the number of black cells in the row equals the number of white cells in the row. Also, the number of, for each column, the number of black cells in the column equals to the number of white cells in the column. So finally, we have to print, instead of these, we'll print like instead of LR means that this is the left part of the domino. This means that this is the right part of the domino. This means that this is the upper part of the domino, and this means that this is the down, like the below part of the domino. So this is one domino, right? So similarly, this is one domino LR. So if it's possible, we'll print something like this thing. So this should be white, this should be black. This should be white, this should be black. Like this is how we'll color. Otherwise, if it's not possible, we'll print -1. And by the way, why is it not possible in this case? If you'll see, I have three domino cells in this row. So in this row, I cannot have an equal number of black and equal number of black and white cells. Why? Because in order to be both of them to be equal, the total number of colored cells should be even. So if total number of colored cells should be even, the number of dominoes that are like the number of domino cells that are in this row or this column, in this column should be even. Are you getting my point till now? Yes, no, anything? Okay. So one thing is clear that in every, first of all, see if this is our grid, n cross m grid, first we can simply check, just like remove these dots. So we are having some LRs, U down, up, down, and then up, down, LR. We are having something like this, right? And all the others are dots. So first, for each row, count how many places are not having these dots. So if for any row, the number of places which are not having dot, like they are having either L, R, U, or D, if the count of these cells turns out to be odd, your answer is no, or no, your answer is -1 directly, right? Yes, no, anything. So similarly, you'll check for each column the number of cells which are having either an L or an R or a U or a D. If the count of these cells for any of the columns turns out to be odd, then again your answer is -1. Is it okay? So after discarding these impossible cases, now how to solve this problem? See, if we are having these even, so forget about L and R for a minute. Why? Because let me tell you why. See, let's say this is the first column. Forget about L and R. Why? Because if there is a domino which is placed horizontally, for this row, I surely know that the cells that need to be colored are even numbered, right? Because I've already checked it. So if it is even numbered, let's remove these LR cells. Why remove these LR cells? Because they don't, like, these dominoes will never change the parity of the number of cells that need to be colored. Because let's say this is L and these are already appearing in these already, like LR always appear in a pair if you look horizontally, right? So these cells will be colored, both of these cells will be covered. So a domino, if it is placed horizontally, will take two cells from this row, which need to be colored, right? So my point is, if there are some cells that are having a domino placed vertically, they will always be even, like the count of them will be even. So if there is an up down here, there will also be an up down somewhere, like in this row again. Like these vertical dominoes will also appear even number of times. Why? Because I've already made sure that the number of cells that need to be colored in this row is even, and the number of dominoes that are placed horizontally won't change the parity of the number of cells that need to be colored. So finally, the number of dominoes that are placed vertically should be even. Is it clear? Like if you'll have three cells like this, like three dominoes which are placed vertically in the first row, then the total number of cells that need to be colored are 5. Right? So this is not possible. Is it clear? You can unmute yourself, or maybe just write in the chat. Is this point clear? What about others? Yes, no, anything?
If n is odd, then only it is.
No. If n is even also, let's take n as even. Let's add one more row here. Okay, one more column here. Is it okay? Now m is even. Okay. So now also you cannot have this u and d here. Why? Because if the number of vertical cells is odd, these dominoes that are placed horizontally won't change the parity of number of cells that need to be colored in this row. So if I have already checked, like here, I have already checked that the cells here, I have already checked the cells in this row that need to be colored are even, right? Because if it was odd, I would have already printed -1. So if it is even, then this thing is not changing anything. So there should always be even number of cells that are placed vertically. Is it clear now? In this row,
In total.
it can be either 0, 2, 4, anything, but it should be even. Is it clear?
Okay.
So now what can we do? See, if they are even, forget about this L and R, you can just color the first cell as white. Okay, I'll use another. You can first just color this as white, this as black, then another one is black, white, white, black, black, white. So just follow this approach. Forget about L and R. We'll solve them later on. So after doing this, when you come to the next cell, since we have already checked that the cells that need to be colored are even, so the remaining cells that need to be colored, removing these horizontal dominoes, now also will be something like up down. If there will be even number of these, right? Again, for the same reason, right? We cannot have odd number of these.
Yeah.
Total number of colors that need to be colored. So if again it is this kind of, we'll again color. Now for this row right now, the number of black cells is already equal to the number of white cells. So we'll again do some same thing. For the first vertical domino, we'll do white, black. For the next domino, we'll do black, white. So this way we'll keep continuing, and all the vertical dominoes cell will be colored. Vertical domino cells will be covered, and each row and each column will have equal number of black and whites. Why? Because for each row we are already checking, we have already proved, and by the way, for each column we are already adding white and black, right, simultaneously for a column. So it will also be the same. So after doing this for all the vertical dominoes, you will have all the rows and all the columns will have equal number of white and black cells. Is this thing clear to everyone? Just okay, if you have a doubt, ask me. Unmute yourself and ask me. You'll have like once try to imagine this, how this is working, or maybe write this down on a paper. You'll get it. But there's no point in going forward if this thing is not clear. If I follow this approach, the number of cells in the rows and the columns that are colored will have equal number of black and white cells. I have not colored the horizontal domino cells right now. I have only colored the vertical domino cells. Is it clear?
Yes.
Okay. So now let's now come to the horizontal. See, horizontal cells are, if you look at your domino, from, let's say, from this side, now your domino is like the cells that were horizontal, now they are vertical, right? So you'll solve them the similar way. You'll keep moving in this direction. And since in this column, the total number of cells that are in this column, I'm talking about this column, okay? So in this column, the total number of cells that need to be colored are odd. So if they are odd, if some horizontal cell was appearing here, let's say some horizontal domino was appearing here, this cannot change the parity or the total number of cells that need to be colored. So the number of horizontal LR that are in this column will always be odd numbered, will always be even numbered, for the same reason that we had earlier, for the same. Okay. If there is a domino, like let's say this is a vertical domino here. So since the total number, I have already checked this total number of cells that need to be colored in this column is even, because if it was odd, my answer would have already been -1. Since the total number of cells to be colored in this column is even, and the vertical dominoes cannot change the parity of the cells that can be colored for this column. So by default, that means that either I will have 0 dominoes, 0 horizontal dominoes, 2 horizontal dominoes, or 4, like this way. I will have even number of horizontal dominoes that are in this column, something like this. So LR, LR, right? These horizontal dominoes cannot be odd numbered. Is it clear? Like the same reasoning. If I'm looking at my grid sideways, this will become the thing that we discussed earlier. This is the same thing like that, right? So now how to color this? Again, let's say this will become like, again, you can follow the same approach. This will become white, this will become black, this will become black, this will become white. Like you'll keep on switching. Finally, all my columns and all my rows will have equal number of black and white cells. Is it clear?
Yes.
What about others? Is it clear? Okay, I'm seeing some people write down in the chat, but what about others? There are other people also. Is it clear? Is this thing clear? Okay, so I'll show you the implementation. So first I'm taking n and m as input, then I'm taking string s as input, then initially f is 0. So this is nothing but, this is a boolean. You can, like, it's not a boolean, it's a flag, but you can consider it as, if it is 0, then the answer is possible. But if it is 1, then one of my rows or columns is initially having even number of cells that need to be colored. So I'll simply print -1. So how to check that? First, I'll go through each row, and for each row, I'll calculate the number of cells that have to be colored. So how to do that? Maintain a count variable and check if s of ij is not equals to dot. So this means this cell needs to be colored. So I'll add 1 to my count. So f or count %2 means that if count is odd, then f will be 1. Similarly, I'll do for all the columns. I'll find the number of cells that need to be colored. So if count is odd, my f will be 1. So if my f is 1, that means one of these rows or columns is having the total number of cells that need to be colored is odd. So my answer will be -1. Then I have a n cross m answer grid. So initially everything is -1. So -1 denotes anything. I'm not coloring the current cell. And 0 means that the cell has been colored white, and black means that the cell has been colored black. 1 means that the cell has been colored black, and 0 means that the cell has been colored white, and -1 simply means that the cell has not been colored. Like it is initially like a dot only. So now how to find the answer? See, first I'll try to color all the vertical dominoes. So how to do that? This is C is just a temporary variable just to know that current cell needs to be colored in white black order or black white order. So I'll go through my current row. If I find that S of ij is U, like I said, the number of these will be always even. So if this is U, I'll color it as this C. I'll color the cell which is below this cell as C. This is XOR 1. So if this was 1, this is 0. If this is 0, this will be 1. So I am coloring them in different colors. If this is white, this will be black. If this is black, this will be white. And then I'm changing the value of my C. For next time, if this is black, this is white. Next time, this will be white, this will be black. So this way, all the vertical dominoes get colored. Then coming to the horizontal dominoes, again, I'll follow the same approach. I'll go through the first column to the last column. Then if my current cell is L, I'll color the current cell with this color. I'll color the cell which is right next to this cell with this color, and I'll change the value of C. Finally, I can print my answer. Is it okay? Okay, someone just unmuted, but I couldn't hear you. Can you speak again?
Is working.
Okay, XOR. See, XOR is basically if you have C as 0, after XORing with 1, your value of C will become 1. If you have C as 1, after XORing, your value will become 0. So it is same like if the last was white and black, now the current domino will be colored as black and white, then white and black. So basically this, you can either do this as also as C++. You each time after coloring the domino, you will take as C++. And if C modulo 2 is 0, then you color it as white and black. Otherwise, you color it as black and white if C modulo 2 is 1. So this also will work. Is it okay?
Yes.
So this is clear to everyone, right? Okay. So let's go to the next problem. So in this problem, we are given that you are playing a video game and this has n quests. So, and these quests, that like the jth quest, can only be completed before har j, at the beginning of har hj. So you're given what hj is for each quest in the input. Then the game is the game day, like one of the day, like each day is k hours long, and the hours of each game day are numbered from 0 to k-1. So basically you have k hours for in each day. So after the end of the first day, second day starts. So usually like we have days. Okay, so now there are some dependencies that for pairs ai and bi, you can only complete bith quest after completing aith quest. You cannot complete this before aith quest. So now it is guaranteed that there are no circular dependencies. Like it's not possible that you should complete B after A and A after B. So this is a circular dependency. Then you are skilled enough to complete any number of quests in a negligible amount of time. So that means that if a quest can be completed, let's say for at the beginning of current hour, you'll complete it immediately, like in no time. And even if there are dependencies like B was needed to be completed after A, and C was needed to be completed after B. So then also you'll complete all the 3 quests if they can be completed at the beginning of this hour. So finally, you have to find the least amount of time that you need to complete the game. So I'll write the problem statement once here. So for each, let me take an example. So let's take example first as 12, 16, 18, and 12. First, you're given n as 4, and then you're given m as 4 and k as 12. So this means you have n is equals to 4 quest. So the completion time, like you can complete this at the beginning of 12th hour, you can complete this at the beginning of 16th hour, you can complete this at the beginning of 18th hour, you can complete this at the beginning of 12th hour. Now the dependencies are 1 to 2, 1 to 3, 2, 4, and 3, 4. Now the okay, this is 24, not 12. So see, you can only complete this second query once you have completed this. So let me draw this thing. Now you can complete the third quest after you have completed the first one. You can complete the fourth after you have completed the second, and you can complete the fourth after you have completed the third. So at the like for the first day, what you can do for the first day, what you can do, you can complete this query on the 12th hour. So now this is first day. Then on the first day, since there are 24 hours, you can complete this at the beginning of the 16th hour. So these are the quest that we are completing. So this has been completed on the first day. This has been completed on the first day. Now both of these have been completed. So you can complete this also at the 18th hour, but you cannot complete this in the first day itself. Why? Because in order to complete this should have been completed, but this completed at 18th hour, and this can only be completed at the beginning of the 12th hour. So for the second day, you'll complete this at 12th hour. So what is your answer? From first day 12th hour to second day 12th hour. So this is 24 hours. Is it clear? How we got answer for the first?
36 नहीं होगा.
Why will be 36? You started from 12. You are not starting from 0 on this day. You're starting from 12. And you're ending at this point. Second day 12.
Okay.
12. From 12, this day will get completed at 24. And then new day will start. And on that day, you'll end all the quest at 12 hours. So these are 12 hours for this day, second half. And this is the first half of second day, 12 hours. So total 24 hours. Is it clear? So now there is only one thing that you need to check. See, first of all, this thing is clear to everyone, right? So this is nothing but this is a graph. You can visualize this as a graph. So for each, you can have a first and a last. Like between these have some dependencies. So this is the first quest, like the earliest quest time that is being solved, and this is the last. So between all the dependency graph, like dependencies graph, I can visualize this as something like if I started this at 12th hour first day, then my last quest will get completed at second day 12th hour, right? So this is what is this graph telling me. So if we combine all these dependency graphs, we'll get something like this thing. Like for so this will give me, if I started this as first day 13th hour, can complete the last query of this dependency component, because there will be some components like this is dependent on this is dependent on this, maybe this is dependent on this, there is some other dependent, like after if in order to complete this, you should have completed both of these. So this, you'll get some kinds of components, dependency components like this. Okay, so from all of these components, you can get something like, if you start query a quest on day 1 at, let's say, some XR, you can complete this. For this, like the timeline is fixed, right? If you start this as first day XR, you can complete this at some, let's say, some third day YR. Similarly, for all of these, you'll get, so if you start this as first day X dash R, you can complete this as second day Y dash R. And for this also, you'll get, if you start this as first day some let's say X double dash R, you can complete this as fourth day Y double dash R. Now the only problem here is, like, this is clear to everyone, right? This is for the all the dependency components from this graph. From the original graph, we'll get some dependency components, and for each we'll get these kinds of information, that if I start this component, like this is a component, right? A separate connected component. So if I start this quest at this time 1x, the final that I'll be able to solve is at this day, this hour. So for each of the components, I have received the different windows. So now only difference is, see, your answer should be, by like technically saying, your answer should be the minimum of these all three and minimum of x, x dash and x double dash, and you'll subtract this from maximum of, this should be 3 times k plus y comma y 3 times k, because this is the time here, right? This is third day YSR. Actually, it should be 2, not 3, because 2 days have completely passed. Let me write this again. So this should be maximum of 2 times k plus yr, or 1 times k plus y dash, or 4, it's 4. So 3 times 3 days have completely passed, 3k plus y double dash. So maximum all of these minus minimum of these, right? This is your, technically this should be your answer, right? This is the time required to complete all the quests, right? Yes, no, anything?
How maybe some dependency don't end at the last day.
No, this is like, these are the components that you'll get finally. Can you explain, like, tell me how this cannot be, like, after calculating the end time, I have calculated what is the time on which what is the earliest time. If I start this as first day, let's say HJR, and this also at first day HJR, so earliest of these will be something like minimum of these. If I start this component at, let's say, the minimum of these hours, HJ values, what is the time at which earliest I can get to like complete this quest? That is what I'm saying. That is fixed, right? That is completely fixed, because either you can solve this on the same day as this, otherwise you cannot solve this, you'll solve it on like the next day, and the time is already fixed. You can only solve this quest at the beginning of HJR. You cannot solve this anywhere other than this time. So for this, you'll get the day and hour also. Is it clear?
What if there was no edge at the last node?
Like this node, you're talking about this node, like an incoming node, or like incoming edge or outgoing edge?
Yeah, the incoming on the last.
Okay, if this is not present, so this is a different component, then this is a different component, and for this you'll get the earliest day and hour when you can solve this, when you can complete this quest. So then this is a completely different component. Is it okay?
Yes.
So then your component just breaks up, right? So for each component you'll get information like, if you start this component at this point, you'll be able to complete the complete component quiz, all the quests that are presenting current component at this hour. So technically your answer should be the minimum time that you're starting, the maximum time that you're ending the component quest at, and the minimum time that you're starting at, right? And why this is 2 times k? Because if you are solving it, if you're completing this quest on the third day, technically 2 days have completely passed. So this is the time. If you subtract these 2 times, you'll get the middle, like the time that has been elapsed since you started and when you ended all the quests, right? Is it making sense?
Yes.
Okay, but there is only one thing that you need to check. See, let's take this example only. So let's say on the first day, your window, like this thing is starting at, let's say, on fifth hour, and you are ending this on third day, second hour, and this is starting at first day, first hour, second day, ninth hour, and this is going till first day, 10th hour, and fourth day, let's say this is second hour. So now if you blindly take the minimum of these values, you'll take max minimum of these values, you'll get 1, the minimum x values. And if you take, let's say, take k as 10, and if you take maximum of these values, maximum of 2 times 10 plus 2, that is the time at this point, which is 22, with this is 10, 19, this is 32. So if you take maximum of all of these blindly, you will get value as 32, right? 32.
Yes.
What? Can you please repeat yourself?
Yeah, 32.
Yes. So if you take 32 minus 1, you'll get your answer as 31. So you are saying that 31 is the time window which you'll require to complete all the quests. But this is wrong. Why? Because instead of starting this component at first day, this component's first quest at first day, I can start this as second day. So if I start this as second day, 2, 5, this will now end at fourth day, second hour, right? If I start this also at second day, now 2, 1, now this will end at 3, 9. So if I start this as 110, if I start this as this at, like I won't change the time of this thing, start time, and this will end at 410, 42. So now the start times will be, for this it will be 15, minimum of 15, 11, and 10. So minimum is 10, right? For this the start time is 15. For this the start time is 11, like 15 hours from starting. So this is 1 day and 5 hours. So that is nothing but on the second day, 5th hour. And for this it is 11. Okay, so 10, this is 10 on the first day, 10th hour. So minimum of these is now 10, and for maximum of all of these will still be 32. So 32 minus 10 is 22. So this is your answer now. So you can shift one of the components, instead of starting it on the very first day, start it on the second day. So what I mean, see, let's say these are the KRs. These are KRs. Then again, these are your KRs. And again, you are having these values. So this way. So a component, if you start here, will get solved till here. If a component started here, you'll solve it here. So but I'm saying start this, like solve this component, and there is another component. If you start here, you'll end it here. So start both of these components shouldn't start at these points. Start them somewhere on the second day, because then they will completely come inside this components window. So your answer will be less. Your complete, like finally you have to calculate the difference between the first start and the last end, right? Last ending time of your quest. So if you shift both of these, like let me show you again. If you shift both of these starting and ending, like both of these components window to somewhere, let's say you shifted these two here like this, and this also gets shifted to, let's say, here. So now these won't exist, so your answer will be decreased, right? Your answer is not the length of this window. Do you get my point?
Okay.
But how to actually, know at which point I should start? See, I just want to know there are k hours on the first day. So on the, like, I won't worry about the second day. I'll just say that I'm going to start at this point, and all the components starting time, if it is after this point, I'll solve them. I'll take them on the first day. I'll take them on the first day. Otherwise, if for all the quests or all the components that are that have starting point before this time, I'll start them on the second day, and finally I can get the maximum also. But if you look at these, the possible values for all of these k times is 10 to the power 9, right? K is going up till 10 to the power 9. So you cannot individually go to first try for 0, then for 1, then for 2, because I am just checking for all the components starting time before this point will be solved on next day, and all the components starting point which are having starting points after this will be solved on this very day. And by the way, I only will do this for the first day. I won't do this for the second day, because if I again start from this is completely same as the earlier one, right? I'm again checking for here, then here. So this is same as checking here and here. So that won't make any like sense. But for these, how to check this? Now the point is, if you don't actually have to check for all of these, you just have to check for n starting points. Why? Because out of all of these values, if these are the k hours, you have only at some places your components starting time, and exactly the maximum number of components can be n only, right? And what is the point of checking? Like, what is the point of saying that you will start your quests after this time when there is no quest when there is no starting point at this point, right? So you'll say, I'll check here if I'll do all the quests before, after, and at this point, all the quests that are having starting after or at this point, I'll solve them during this day, and all the quests that appeared before, all the quests that has starting point before this point, I'll solve them during the next day. So you just have to check for endpoints. Is it clear?
Yes.
Okay, so I'll show you the implementation. So first, I'm taking n, m, and k as input. Then I'm taking h as input. So these are the r's. Then I'm making a graph after these. So from like v can only be completed after you have completed u. And I don't think this, like this is just for assertion, so I don't actually need this. So then after this, initially I'll assume that each of my quests can be completed on day one. And this earliest is nothing but, like I said, for each component, I want to know if I'm solving this at day 3 sometime, then what was the earliest at this component, like what was the time at which this component gets started. So then coming back to this place, now since, okay, one more thing, in my graph the dependencies are like always like a is less than b. If you read the input, like if b can be solved only after a will always appear before b. So this has dependencies like only like this. There is no dependency like this. This doesn't exist. So I can simply iterate over this, right? Because if I'm at this point, I'll simply know that there is no other quest on which this is dependent that I've not worked on, because these kinds of dependencies don't exist.
Okay.
Okay, so now coming to back to here, if my earliest, like initially I've initialized everything with 118 earliest. So if my earliest is 118, I'll make earliest, like this is the starting point of my component. So if this is the starting quest of my component, I'll make the earliest of u as h of u. And then like I'm doing it for every node, but you don't actually have to do this for every node. You can just do this for the last nodes, like the last nodes of your component. But it doesn't make any difference. Why? Because I'll tell you. Like this is just for avoiding some calculations. So you can do this for your ending nodes only. But I'm doing this for each node. I'm calculating the window for each node. Anyways, the window for this node, which is coming afterwards, will be more than this node only, right? So this can be easily shifted in this part only. So like I said, for each component, you should have the starting and ending, right? But instead of having for each component, I'm having starting and ending for each node. It doesn't change anything. It just simplifies my work because, see, a component can be like this also, right? So in this, there are two ending nodes. So first you'll have to check which of these is having earlier start time. And for this, you'll have this component, you'll have two windows. Like you don't actually need two windows. You just need the earliest of these two and the maximum of these two. So this will give you the time frame for this component to get completed. But instead of having this complication, I'm just having start and end for each node. So start and end for this node will be also there, and start and end for this node will also be there. And one of these will be bigger. So if one of these is bigger and one of these is smaller, so this is in this only, right? This matters. This actually doesn't matter if this is smaller. So that's why I'm having this for each and every node. And how to calculate the window? Earliest point at which the current component quests got started or completed, and number of days, like I said, k, like I was doing k minus 1, right? So I was doing number of, like, where is it? So while I was calculating the ending point, what I was doing, I was calculating it as 2 times, if the number of days was 3, I was doing 2 times k plus y. Y was the hour on which this quest got completed. So this is days of u minus 1 if it is completed if it is getting on ith day completed, then if it is getting on uth day completed, then it is days of u, like it's not getting completed on uth day, it is getting completed on days of u. So days of u minus 1 times k, this is just long, so that I don't have integer overflow. So this is days of u minus 1 into k plus this hour. So at this point, this very quest will get completed, and this is the starting point for the current component. Now, for all the dependencies that are because of this uth quest, what I'll do, I'll check if h of v, that is the time at which the vth quest can be completed, is less than u. So I can only complete this quest on the next day. I cannot complete this quest on this day. Why? Because v can only be completed after u. So I'll check if day of v is less than 1 of day of u. I'll update earliest of v like this. But otherwise, if day of v is already equals to this thing, then I'll take minimum. Why? Because it's possible that earlier also I was having some earliest value because of some other node, right? Like I said, this thing is also possible. Like this thing is also possible, this kind of structure. So this node will have earliest from 2 values. So you'll have to use both of these nodes to calculate earliest of this node, earliest point at which this current component gets started. So if this value is anyway equals to this day of v, I'll do this thing. Otherwise, I'll calculate it completely. Finally, days of v is now, like for this case, it's 1 plus days of u. For this is equals to this only. So I'm doing days of v on which I can complete the vth quest is equals to maximum of either this thing or this thing. I can only complete this vth quest after this day, days of u. Otherwise, if this is more than h of v is more than equals to h of u, this means that the vth quest can be completed on the same day. So in that case, if days of v is equals to days of is less than days of u, like the same logic, I'll update this completely. Otherwise, I'll take the minimum value of the earliest values. Otherwise, now like here I did 1 plus days of u. I'm not doing 1 plus days of u. Why? Because this vth quest can be completed on the same day also. Finally, I'll sort all these windows. Now after this point, I'll have all the time windows, right? So I'll sort all the time windows, and this is my answer. So there are two multisets. The first multiset will have all the quests that can be started, all the components that can be started on the first day. M2 will have all the components that are getting started on the second day. So initially everything is getting started on the first day. So I'm inserting every ending point of each window in the second, in my first multiset. Then, like I said, we only need to check for all the starting points of the components, right? I don't actually have to check for each and every value of k, like here. So this will only go for each values of starting points. So for each values of starting points in my VP, I'll take maximum from current multiset. If second multiset has size, I'll take maximum from that also. And my answer is minimum of answer if I'm ending at this point and I'm starting at this point. Now, for the next, now I'll now shift my current, like this was my current starting, right? Let's say this is my starting and ending. Now I'll try to shift this from current day to next day. So let's say here my day ended. So I'll shift this window to here. So how to do this? I'll insert k plus ending. Now this is the updated ending time in my second multiset. You don't actually have to do this. You can do this simply in M1 also, and you don't need M2. But just for simplification, I'm doing this. And you can also erase this value from M1. Like you can, but it won't change anything. Why? Like I can do M1 dot erase, M1 dot find this en, but actually it doesn't change anything because this en value is anyway not great. Anyway, is not greater than en plus k, and I'm taking maximum of from this also. So this won't change anything if you're removing this also. Finally, I can print my answer. I hope this is clear. Like this is having a little bit kind of DP implement DP plus your what do you call that? So I won't say it as I don't remember the name, but that sorting. What do you call this?
Topological.
Yes, topological sorting. So this is kind of topological sorting, not exactly, But anyway, you are only coming to a quest when all the previous quests have been completed, right? So this is kind of topological sorting plus some DP. So this part is here DP, and topological sorting is basically this thing only if I'm going in this order. Finally, you'll have to adjust. So this is greedy part. So like you'll get the complete intuition once, like you write it down. Like you'll have to write this down once. So I hope this is clear. And that's it for today. Like we're going to discuss these problems only. So, and kindly fill the feedback form also, like the feedback that form that is provided by managers. So thanks a lot and bye-bye.